and welcome to SOLIDWORKS Skills video.
In this video I'll be doing a demonstration of worksheet 6. This may be a little bumpy, but I'll do my best to get through there as quickly as I can. You should have a copy of worksheet 6. It's always helpful to have an actual printout in front of you to be working against. That's what I have. This is the finished product. You've seen this in lecture. So let's go ahead and create a new assembly, and I'll basically redo exactly that. So I'll go to File, New, Assembly. The first thing I'm going to place is one of the shaft clamps, and a teaching moment here. If you want to place multiples of an item, if you see where I'm pointing here at this keep visible, this pin, what I can do, I'm going to scroll out a little bit, is when I click to place one, it is now still in the placing mode, and I can put another one in. I will do that. Notice the cursor changes, and I right click, it will complete the operation. So now I have two of those, and they're not oriented at all. Let's continue the process. I'm going to insert a couple more components. I'm going to insert the two 12mm shafts, and I'm going to again click on the pin so that I can get two of them without having to do it twice. I got 1, 2, right click, and done. So let's go ahead and create the first mate constraints. I know that I want these to pass through the two blocks, and I want the blocks to be spaced out a certain distance from each other. Let's do the first block. So I'll go into mate, scroll in a little bit, click on the outside of that, go and find my way into the inside of that. Now they have a concentric relation, and I will accept that. It's waiting for me to do more. The next thing I want to do is to make this edge coincident with the end here. They now are. I will accept that. Next, here with here. I don't feel I need to give too much dialogue here. You can watch as I do the operations. Let's get to the end here. So now I have that part ready. Let's accept that and continue with the other end. Now, I know because I created this, that the dimensions will work, but I want to work per the worksheet. So if we go to the second page, there's a distance relation between the insides. If you look at it, it's between the inside surfaces. First off, let's get the concentric constraint set up. That is concentric with that. I'll accept it. Notice I can still rotate. That helps me because now I can click on that, and now they are, it's lined up with the two shafts, but it's movable, which is fine. Let's set up a distance constraint between here and here. Right now they start out coincident, and according to the worksheet it wants to be 488.95 millimeters, which brings it out to the end. So I've got a good starting point. Let's continue with adding items that we know are part of the assembly. There are the slide bearings to bring in. So let's go out and go to Insert Components, and it looks like I did not open that already. I'll go out and find it in my, give me just a moment here, I've got to find it. It's in my Google Drive. I've got to hunt it down. Apologize for the delay. Sample assembly, and I should find the slide bearing down here. There it is. It's a SOLIDWORKS part. Double click on it. Now again, I want 4 of those, so I'll click on the push pin. 1, 2, 3, and 4. Right click to finish. Now I've got the 4. Let's start to constrain these on the shaft. So I click on mate, the inside, and the shaft. Now they're concentric. I'll accept that. I'll show you a shorthand for accepting in a moment. Click on this guy, and the shaft. And notice I can choose other mate constraints. It happens that concentric is good, so I'll click on the checkbox. I'll show you one more accelerator, there and there. And if I don't move, notice that the cursor shows me the right mouse button will accept it. So I'll do that. And we got one more to do, that guy with that guy, accept it. So you can really work pretty quickly through this. I know that I want these all to be coincident. That's it. The face of that coincident with the face of that, and so on. I'm going to set that up right now. That with that. It's already selecting coincident. I'll accept it. This one with this one. Right click. And this one with this one. Right click. So they're all coincident. Now they can't rotate on the shaft, but they can move. If you again refer back to the diagram, let's see which page it's on. Looks like the 4th page. So there's a dimension between the outside of the slide bearings. So from here to here, right now it puts them as coincident, but in fact I want a distance, a control distance, and that is 116.281. If you're wondering where these came from, they were probably English dimensions that I converted to millimeters. So I'll accept that. Looks like I made a mistake. Let's go back and fix that. Here we are. I neglected to say millimeters. So I'll go back and say mm. Should bring it back into the picture, which it does. So easy to fix error. Now you might think that I need to now do the same thing with the bottom two, but by giving a coincident constraint between here and here, now they're lined up, and between the other pair, here and here, I'm done. So now, if I come out of here, they will move as a unit, so I've already got the first part of this assembly ready to use. I'm going to stop here and then I'll continue in just a moment. Alright, continuing on, let's bring in the DeWalt router and orient it, locate it such that it is where it needs to be per the design. I'll go to Insert Component, and there's the DeWalt 611. There's only one of them, so I won't bother with the pin. And of course it comes in oriented in a fashion that is not particularly helpful. There are any number of ways to get this located properly, so don't take what I'm about to show as the definitive method. It's just a method. Now if I go up to visibility, you'll see that if I turn on view axis, that in fact I can see that because when I designed these various parts, I put an axis. You can see it in blue here. There's an axis for each of the shafts, and there's an axis for the DeWalt itself. You can also see that there are some flat surfaces on here. There's a flat down here. I think what I'm going to do is to start to orient the router so that at least it won't try to tilt on me when I do some of the things I'm about to do. So I'll go into Mate, pick one of the flat surfaces on the bottom, and I know because it's a fairly simplistic design that I want it to be parallel to the flat on the slide bearing. I could have picked other surfaces. This is just a convenient one. Now let me change my mate alignment because it's upside down. I want it to be this way, and I don't want coincident. What I want is parallel. Sometimes SolidWorks undoes things, so there we are. We're there now, parallel, and that's all. No other control. So I'll accept that, come out, and you'll see that now I can move this. I can move it left and right, pretty much any location I want to. I'll get it approximately oriented the way it ought to be. And I'll zoom in a little bit. You can see that it's kind of where it will eventually end up. So let's add another constraint, again referring to one of the diagrams. It shows that the distance from the center line here to either of the axes of the shafts, for example, that there's a certain distance. It happens to be 57.150 millimeters. So I will add a mate, and it'll be a distance mate. It'll be between here. I'll go right to distance, and I'll click on one of these. Right now it's just set for 1 inch, but I'll punch in 57.150 millimeters, and now there it is, located in a fashion that is useful. So I will accept that, and I'm not quite done. I mean, there's a couple of other ways that this can move. You see that it can move left and right, it can move up and down. All I've really done is to control that it cannot move left, further or away from the shafts. So let's see what other dimensions it is asking to provide. I see that there's a vertical dimension of 93.142 between the upper shaft and one of the bottom flat, this big flat on the bottom of the router. So I'll go back into mate, click on, I'm waiting for it, let's clear this, I don't want it automatic, and I'll click on this surface. That's one of my references. I'll click on distance, and it's the axis here. So right now it's just 1 inch below, but what I really want is 93.142 millimeters, 93.142 millimeters, and I accept that. So now I have a vertical orientation. So you remember that there are several degrees of freedom. So I haven't done the left to right, but I have the up and down, which is now locked. Notice if I try to tilt it, or move it, it just tilts, and I can't pull it away. So I'm nearly there. Here's where we begin to need a reference plane that bisects the slide bearings. So I'm going to go ahead and create I'm in assembly. I'm going to create a reference geometry or a plane, and that plane will go, let me clear this out, I don't want anything in there. Alright, it'll be between here and here. So there'll be a bisecting plane, and that's useful. I will leave it selected. Notice it's currently selected. You can see by the appearance of the handles. If you click away from it, notice the handles go away. In fact, I can't even see the plane at all. Now I can find the plane over here in the feature tree. By clicking on it there, I can find it. Or I can go back into the visibility section and turn on plane visibility, in which case every plane becomes visible. Let me turn that off. I think it was actually a little easier to just pick the plane here. So that I've selected the plane, and what I'm going to do is to make that plane and this axis coincident, that axis lives on that plane. So I'll do a shift, left click, and up comes the accelerator. I can do things. One of them is coincident, and that's the one I want. So I'll click on coincident. I don't know if you saw it, but it moved the motor, and so now finally that router is completely and accurately located, ready for creating the new parts. So I'll stop again here. This is an apt moment to remind you that in-context part information is saved within the assembly file. Therefore, you must save the assembly file now before creating any in-context parts. Otherwise, serious problems will occur, relations will break, etc. Alright, continuing on, I have the router mounted as I want it, and I want to create a new part, the mounting plate that will be flush with and aligned with the slide bearing. So I'll go into Insert Components. Instead of inserting a component, I create a new part. And that new part will be referenced to this surface of the bearing. I click there, And now I'm ready to start the sketch for that new part. So I'll click on rectangle, and I'm going to align it with the outer edge. I click once and start dragging. I can rotate around, get myself oriented, and make it align with the lower right corner. Click again. There's my outer extent of the rectangle. I'll accept that. Let's convert some entities. I'm going to convert all of these holes, all 16 of them. Takes a moment. There may be a more efficient way to do it, but this is not too bad. Get all 8 on that side, and then come around and do the same thing over here. Notice I'm converting entities, and they're accumulating in the list on the left. Each one I click on shows up in the list. Alright, a couple more. So now I've done that. I will allow that to be the sketch. So I have an outer rectangle and the 16 circles. Let's finish the sketch, and I'll go up to Features up here, Extruded Boss Base. Let's find that sketch in the list down here. Notice the feature tree moved out into the working area. Click on Sketch 1, and I'm going to punch in the depth that I really want. Again, referring to the document, it's 5.080 millimeters. I will accept that, and there I am with the beginning of that new part. I'm going to come out of the part for a minute just to look at it in context, and before going any further, I want to save my work. Right now it's called Part 4. It's an incrementing thing. I'm going to right click on it and I'm going to rename the part. I will call it, let's see, originally I'd asked you to give it a name, but I'm going to give it something to avoid conflict with names that I have for parts. So I'll right click on this, rename part, and I'll call it Mounting Plate 2. Alright, press enter. And I'll right click on it to save it in an external file. So now it is ready, it's saved, and I'm going to stop again. I assume that this was not too complex, so let's pick up in a moment. Now we're ready to begin developing the feature that would support the router, the shelf. And so let's go ahead and do that. We've already got the router positioned. We've got a base plate. Let's create that shelf. The shelf itself, I'm going to declare that I want the upper and lower shelves to be aligned with the upper and lower shaft axes. I will create an axis, a reference plane. I've clicked on the axis. Now I'll click on the top surface, and I'll make it parallel to that top surface. Oh, let's fix that. Delete. I clicked on an edge. What I really want to click on is that surface. I'll make it parallel to that. Alright, so now I have this reference plane that cuts through the center of that shaft, and that's where I want my upper shelf to live, to be centered on that. So I'll right click and edit the part, and now I'm ready to do some creation of that feature. I'll go into Feature, Extruded Boss Base, and I will click on that new plane that I created, that one right here, and let's convert some entities. I know I want it to be aligned with the front edge. See this edge I'm highlighting, so I'll convert that, and you'll see a line appears. I also want to cradle the router, and that is defined by the periphery. This circle is a convenient reference, so I'll convert entities of that circle. So now I've got the two of them, as you can see, the circle and the line. Let's create some of the additional geometry to finish that up. I'll create a line. I will start it in the corner over here, and notice it helps me, and if I zoom in a little bit, you can see that as I move down, a blue line, a dotted blue line will appear, which is in line with the center of that circle. So I'll click here, go over to the circle, touch off there, double click to finish it. Now I've finished the left side. Let's do the same over here on the right. I'll start my line, come out, find my dotted blue line, there it is. Come over to the circle, find my point there, double click, and now I have finished that most of that geometry. I do need, however, to trim the circle that's out here. See that circle? I only want half of it. I want the inner half, not the outer half. So I'm in trim, drag across, it goes away. I'll accept that, finish the sketch. Now I'm back in my extrude mode, and I want the thickness to be, reading off the sheet, 9.525 millimeters, and I want it centered. So I want mid-plane, centered on that plane, and now here I am with the upper shelf conforming to all of the features of interest. I'm going to finish out, and in the next little section I'm going to show you how to mirror that feature around the center of the part. When we want to put the second shelf on, we could simply repeat everything we just did, but that's wasteful, particularly since the bottom shelf, other than its location, is identical to the upper shelf. Instead, let's open up the part and go take a look at it. There's our upper shelf. And I'm going to declare, again, because it's on the designer, is that I want this to be repeated, mirrored around the center of this entire part. I believe that that will work fine. I will create a reference geometry, a reference plane, which bisects the part, and that will be my mirroring plane. Click on top and bottom. There's my new plane. Let's make it a little bit bigger for visualization. And if I click away, that's fine. Let's mirror. We're going to mirror around that new plane. I'll click on that. That's my face plane. And the feature to mirror is the latest boss, this guy right here. You'll see it shows it as a preview. And if I click on OK, here I am with an upper and lower boss. And if we go back to the assembly, it will update it. And there, in fact, you can see that it is looking pretty good. So about the only thing left to do other than color to this part is to add the 4 mounting holes. So let's do that. I will again go back to the part. I don't need to reference anything right now because these are independent rather than dependent in a way. I'll do an extruded cut on this surface. I'll do a center line. Notice I can find the center line quite easily of that edge. Draw straight down, and let's create a circle based on the middle of that line, which will be the middle of the entire feature. You might be wondering what diameter I should use. This would depend very heavily on the hardware in question. Generally, what you would do if you have, and this is true in for assemblies where you're using a screw, is you'd want the outer hole, the one that the screw passes through easily, to be a clearance diameter, and the one that it interferes with would be either threaded or small enough that the screw itself would cut the thread. Because this is a simplistic exercise, I will simply go back to here and I will repeat the diameter. This is okay for right now. So I'm going to evaluate. Notice I have tabs. I click on the evaluate, measure. I'll click on the circle. It's showing the diameter to me in millimeters. I could also see it in inches if I chose. If I click on here, click on inch or millimeter. Let's say I want inches to be my unit. It'll show me, and the diameter in inches is 0.166 inches. So okay, I'll close this window. Let's go back to the part now. We're still in the sketch there. And I'm going to dimension that circle. Here we go. And we'll make it 0.166 inches in diameter. Looks good. And I'll accept that. We can extrude all the way through. For right now, that'll work fine. I'll go through all, and we have our first hole. Just like I mirrored before using this plane, I could mirror that hole. In fact, that's what I'm going to do. Keep my life a little simpler here. Let's create a vertical plane as well. I don't think I already have a plane like that, so let's create a reference geometry, a plane which is a vertical bisecting plane between here and here. So now I have the part bisected in both directions. And I will do a mirror. Let's click away. We'll mirror. This be the plane. The feature is the hole. So there I see my bottom hole. Alright, so now I have the two holes mirrored around the horizontal center. Let's do the same thing for those two holes mirrored to the right side. So we'll click on mirror one more time. Mirror around this plane, and we'll select one hole and then the other. Accept that. So now I have my 4 holes all the way through that are usable for creating my clamp. If I go back to my assembly and it updates, so now I have the assembly waiting for the additional part. Before we finish, let's change a color. I'll change appearance. For the mounting plate, I can do this right inside here, and it looks like it wants to be some kind of bluish purple. That works for me. Maybe a little more blue. Yeah, I think I like that better. Okay, there we are. So now we've done the color, and we're ready to move on to the mounting clamp. I will stop here. The last part to be added to this is the clamp, and that will be placed around the front of the router and with an intentional gap of 1.270 millimeters from the mounting face. We'll create one and then use a duplicate for the bottom, so we'll create one on the top. Go into Insert Components, New Part, and this will be related to the top surface, and if you look at the geometry, it becomes clear why. Here we are now in the new part, beginning to edit it. The first thing to do is to create the gap, and I'll do that. There are other ways to do this, but I will use the offset entities, and I'll offset the front surface out by 1.27 millimeters. And I'll do the same thing on the other side. It will retain that number, by the way, for the next operation, so I don't need to punch it in every time. I'll offset entities. Again, this front edge. Accept that. And as before, we'll use the periphery of the router body just as a simple convert entities, which is this circle up here. Accept that. So now I have a circle and 2 lines, but what's interesting about it, let me see if I can find the point at which they're, notice that they don't actually touch, and that makes sense geometrically because even though it's a slight offset, that 1.27, it's enough to cause a measurable and calculable gap, and you see the gap right here between that point and the newly converted circle. So we need to drag that point over to be in contact with, and takes a moment for it to accept it, but there we are, and I've dragged it over. I'll do the same thing on the other side, because if they don't intersect, it will not be able to complete the extrude operation, because it's an incomplete area. So there we are. I've dragged that over. Let's continue. I'm going to create now the wall thickness of the part. I can do an offset entities again from here. Let's see if I can include the circle. Yep, I sure can. And I'll include the other line, so the 3 here. And the amount of offset, now we're looking at the wall thickness, and it's defined in the document as 5.08 millimeters. Let me make sure I have that right. Yeah, 5.08 millimeters. And so now it's extending out its offset from those 3 surface lines. I'll accept that, and now we have a little bit of cleanup to do. We've got some extra lines. Let's finish the outside though. These 2 points need to be connected. Got the same thing on the other end. Those need to be connected. So I've done that. And let's finish up by cleaning up. I'll go into trim entities. I want to get rid of that and that, here and here. So now I've got a clean transition. I'll do a similar thing on the other side, clean up that and that. And here we are with a fully closed area. I will accept that. I can come out of the sketch, and now we have something that can be extruded. Well, this extrude will want to go down as far as to the bottom of the protrusion of the other part. So I will go into Features, Extruded Boss Base. It's this. We'll go up to Surface. I will choose the surface I want it to go up to, which is the bottom here. And with any luck, there is the beginning of our part. And we can go back to the assembly. Now before I go too much further, just as before, I want to give this part a name, and I want to save the whole thing so I will not be able to lose my work no matter what happens. So I'll rename the part. We'll call it Clamp 1, and we'll save it in an external file. Okay. In fact, let's do a file save all. That way the assembly is saved, all the parts are saved. Okay, now that we have this clamp, I will open the part. Let's give it a color. What I've learned is that if you apply a part color within an assembly, it's true only in that assembly, whereas if you apply it at the base part, it travels with it no matter where it may be used. So that's something interesting to know. We'll go to Appearance, Clamp 1. I will select a green color, much like the example in the worksheet. Go back to my assembly, it'll update, and sure enough, there it is, green. Just for reference, let's go back into the part here and we'll see the same thing. Remember, I had applied a color out in the assembly and it did not travel back through the part. So let's do that here. We will do a right click again, Appearance, and let's give this that color we gave it before, which is that kind of purpley blue. Okay, and we'll go back to the assembly and we're good to go. Alright, so now we have this clamp, but it lacks the holes, and these will have to be done in context because otherwise I won't know where they go, and I do not want to apply numeric dimensions. So let's do an edit part here, and we'll do an extruded cut on this face. We will do a convert entities. Now here's something, another learning moment. You can change how the view is presented. Right now it's presented as a shaded with edges. If I go down to a wireframe presentation, what you'll see is that that enables me to choose features that might otherwise have been hidden. I was, for example, having trouble getting to this circle, but since I'm in wireframe mode, I can get to it, so I'll click on that, and I'll go over to the other side, and it's actually much easier now. I'll click on the same thing over here, accept it. Now it's projected to the front surface. Let's go back to the shaded with edges. Okay, so now we're back where we were a moment ago. I want to finish the sketch. I'm going to allow it to cut all the way through. And now we have the two holes ready for screws that can be placed into them to hold it together. We'll come out of the part editing altogether, and let's insert now a second instance of that clamp. So I will go to Insert Components, Clamp 1, here it is, and let's start mating it. Okay, there to there, good. Let's do bottom edge, bottom surface to bottom surface. Okay. Did I get that right? Nope, it's below it. Let's flip that over. That's better. Okay, good. And now we can bring it over to be in alignment. We'll do that edge to that edge. So now we have complete alignment. Let's do a file save all. Don't want to miss the opportunity. Alright, I've placed the two parts next to each other. That is the screw that's going to go in the holes. I've sized down the window a bit because I can zoom in whenever, as much as I want, and pan around. So let's start dropping the hardware in. I think I showed this in one of the other tips videos. Drop a screw in. I'll do it again and again. We've got several to do here. And because of the automation, this is one automation again that I do like. You can populate the hardware very quickly. Here we are, we're nearly done. And I noticed that I had not yet added the fillets to some of the parts, the new parts. So we'll do that in just a moment. But again, I want to save what I'm doing here just for safety's sake. Add a couple more. 1 and 2. Okay. We can re-maximize this window. Observe that all the hardware is now in place. Let's do a file save all. Rebuild and save. Yep, that's what I want. Let's continue a little bit here. I'm going to open up this part, add a couple of fillets to it. If you notice in the worksheet, it talks about wanting a fillet. Let's see what the numbers are. Fillets are added. They're all 0.1 inch radius, and they're not everywhere, just a few of the select locations. So I'll go up to Features, Fillet. It's already 0.1 inches. We've got one there, one on the bottom, top and bottom of both of the shelves. So I think that's the fillets for this guy. Again, let's save. File save. We'll go back to the assembly. Alright, let's see. Models have changed. Yep, I want to update it. Alright, so here you can see the fillets. We have a couple of fillets to add to the clamp, which I'm doing right now. Same diameter or radius. So go to fillet. In here, these fillets help reduce the likelihood of cracking or breaking. Gets rid of some of the stress concentrations on those interior corners. They're not cosmetic. They actually do have a functional purpose. Alright, so we've updated the assembly. Let's do a file save. Yep. So now I think we're there. Confirm that it still moves. It shows all the features that are supposed to be in it. I think I've got the coloring right now, and I think this concludes the demonstration of the Worksheet 6 creation.
Thank you for watching. This video is part of a series created by Neil Rosenberg and Joseph Caswell. All rights reserved.